Hello, everyone. How's it going? Get some snacks in you? So we were happy to hear the positive feedback from the tour yesterday. I wasn't able to attend it, but Steve said that it was a success, I guess.
Yeah,
so
really
it's
well.
fantastic to hear that. So this presentation is basically going to be focusing on our BIM process, some of the obstacles that we came across, some of the technologies we leveraged, just how we collaborated and coordinated as a team. So yeah, with that, we'll get started with some introductions. So my name is Tyler Buhr. I'm an associate partner with Henry Downing Architects. I've been with them for 7 years. I've been manager for 5 of them. A little bit about the company. Henry Downing has roots in architectural practice within Saskatchewan for 50 years. Our portfolio shows a variety of projects in many different sectors, including education and research, office and commercial, healthcare, recreation, and a number of different sectors. So my role in the company has been to integrate and manage the data going into these models, enhance the BIM collaboration and workflows within the company, and to lead projects in the BIM regard, like the Children's Hospital. So I'll pass it to Steve for his introduction.
My name is Steve Schiml. I've been with Wingerak Engineering since 2009, and I've been a part of their BIM implementation process pretty much from day one. Wingerak is Saskatchewan's largest Saskatchewan-based mechanical engineering firm, specializing in HVAC for institutional, educational, commercial, medical, and laboratory facilities.
All right, so let's get started with some project facts. There was 9 consultants involved in this project. We had teams from Ontario, Oregon, Washington, and Saskatchewan. We had 17 models making up our BIM atmosphere. The building included over 31,000 square meters in building area with over 1,200 rooms. It took 824 construction document sheets, excluding specifications, to compile the drawing set. We used 7 versions of software, and there was 8 mechanical ventilation systems, which Steve will touch on a little later on in the presentation. All right, let's start with the models. So 17 models. I think both of us can agree it was fairly... I guess we start with the consultants. Sorry. So 2 architectural, 1 structural, 2 mechanical, 2 electrical, 1 medical equipment, 1 landscape. We'll talk a little bit how we broke up these models in regards to the consultants later on. So 5 architectural models, 3 structural, 4 mechanical, 4 electrical, and 1 medical equipment. Now these models were strategically separated to accommodate a number of different factors, including file size. There was a natural separation architecturally with our collaborative architectural partner from the States, who are a specialty in medical design. So we separated the architectural models with the building and the envelope and the interiors model. And Steve will kind of break down the logistics behind the mechanical.
Mechanically, we broke into 3 separate models. We had an HVAC model, so that was all our heating, ventilation, air conditioning, hydronic piping. We had a plumbing model, which was all of our domestic plumbing and medical gas services. And we had a fire protection model. We broke these models out specifically that way for the model management side. As you can appreciate, on a building this size, with everything inside, the model starts to balloon and becomes almost unmanageable. We looked at a couple different options of how we would break it up to keep all of the systems together. We looked at specifically breaking up by floor. We broke it up by floor, though. We didn't think we had a true BIM model at that point, in that floor by floor being different models, they wouldn't connect directly back to each other. So if you selected an element, a duct or a piece of pipe, for example, it wouldn't know the flow through the different models. So we broke it up between these 3 disciplines, and it worked pretty well. That being said, our HVAC model was still 365 megs.
600
megs, yeah. So it's about 4 times, 5 times larger than a typical model that we use. So it just goes kind of to show how much information we really did put into everything.
We also had models representing the RUH and the parkade that we were connecting into. Okay, so we had over 31,000 square meters in building area, the majority of that over 10 levels. There were additional levels to the building for time purposes to RUH and the parkade. The building, again, consisted over 1,200 rooms. Basement levels host the building operation spaces and generators. We have a helipad on the roof and a mechanical level below. And just, again, 824 construction document sheets. We found that number to be impressive and kind of daunting out of the gate, but
824 A0 sheets.
A0 sheets, so there's a lot of information on those.
Biggest sheet you could get.
So we'll move on to the software we used. I'll let Steve talk on that.
We used 7 different versions of Revit. I believe the first version of Revit we started in was 2010, and we just recently upgraded in the last month to version 2019. As you can appreciate, there's a lot of different changes specifically to the MEP on those different versions. So we had a complete process that we worked out with the teams on how we would upgrade those models. And for the most part, it's gone very well. We use Revit, some other softwares, Revit of course. We use AutoCAD, Navisworks for some clash detection, SketchUp, and Design Review. We had 8 separate mechanical ventilation systems. What Revit allowed us to do specific to those systems is break them out really easily. As Edwin mentioned with color jumps out of the page at you. We were also able to separate those separate systems into their own individual drawings. So our overall working drawings were a bit of more of a coordination with all of the different mechanical systems on it. Those are the sheets that we annotated and everything for coordination. But then we broke it out specifically on overall views for the different duct systems individually. So an individual exhaust system, supply system, return air system, to give the contractor a really good general overview of where everything was running and break it out clearly as they're working through the individual systems.
All right, so we're going to talk a little bit about the design process. So the design process is always a fun one as the information is coming from so many different paths, and this differs from project to project. So we're receiving sketches, verbal ideas, physical models, just a number of different sources. So it's up to us how to efficiently bring this information together, take the conceptual ideas and drag them into a BIM atmosphere. And this, it's not just to understand the geometry of the building, it's also to start prepping the BIM for the data that's going to be used in it and for the future use of it. Move on to the AutoCAD. Oh, sorry.
So AutoCAD was another software that we used. The early stages of our model focused on the flexibility. Sorry. As we start receiving more refined drawings with more specific information to the spaces, we start flexing our geometry to meet those different area requirements.
Yeah. So then we received models, SketchUp models, which were showing a little bit more in depth the design intent of the building, what materials were going to be used. And we started bringing that into the BIM atmosphere and applying that data to the walls, the objects, everything that was living within that BIM environment. So again, just another method of conveying design intent that we were able to pull into the BIM. So why BIM? And this has been touched on already in this event, but so we were able to translate sketches and ideas into working drawings before. So the question is why BIM now? So we're going to start with the design again. As we start massing these concepts, we're able to better relate the building to the site and how it interacts with the surrounding structures. Each project has its own unique space planning hurdles. This project had many different user groups and user requirements in regards to space and area. So to assist with this process, we leveraged the model to create formulas to compare zones, areas, departments, and functional spaces to help highlight where we were running short on space and where we could afford to take it from other areas.
The analysis of the building. So being that we modeled it in 3D and in Revit, the software knew spatially in real world where it was. We were able to then export, we had spaces in the area that knew their spatial representation, so the floor area, the volume, window count, door count. We were able to put all of the internal loads in there. From Revit, then we exported to a GBXML to an external software that we were able to do our load calculations. With this, there was a lot fewer manual takeoffs, as you can appreciate. On using an AutoCAD file, you'd have to measure the wall area as a mechanical consultant. You'd have to count the windows and the areas and everything. With an MEP model, the spaces knew all of that already, so it saved a lot of time. We were also able to interact with how the light worked with the building. So both mechanical and architectural were able to leverage that information a little bit differently. Obviously, for mechanical, we needed that for the building load calculations. Architecturally was able to see how the light would play into the spaces and different shading areas that were needed.
Great. So multiple sunlight simulations were done throughout the seasons of the year to get our best efforts to leverage that as a design tool. Now, as far as the client interaction goes, again, this is more back to the 3D portion of the model. I mean, even starting this project, BIM was 3D modeling, it was geometry. That's what everyone knew it to be. We didn't have that outlook on it, but it was just kind of a connotation for BIM itself at that time. But saying that, there are huge benefits to 3D geometry, and one of them is to communicate the design intent to the client, producing renderings and walkthroughs, and just meeting the end user requirement just by showing and reflecting the design before it's built on site.
Some of the data, again, I touched on a little bit before, but we utilized formulas to create schedules highlighting areas that were not meeting the end user requirements. As the conversations continued with these user groups, we used the model as a hub to help organize information and requests pertaining to the spaces, ensuring that we had a functional layout.
Yeah, so and as the design phase came to an end, we started focusing on the accuracy of the model because we knew it was very important to really show the benefits of what BIM is. So once confident with the model, we paired this information with our own historic data to more accurately estimate the cost of the construction. And just a little note here, we weren't off by very much with our historic data with past projects. It was actually, I can't remember the exact numbers, but it was pretty impressive how close we were to what the anticipated number was through historic data. So it was definitely beneficial to help stay on budget. Oh, so the marriage between geometry and information is important in our coordination process. We established a shared parameter file that we used among consultants to flag elements or areas that required attention from a specific discipline. I'm just going to use an example of how we use this kind of method. So we're fortunate enough in our firm to have our spec writer in the model, applying the data. So I think that's kind of rare to see, and hopefully it improves with time, but we're fortunate to see that already. So our spec writer is going through these doors, applying the data so the door knows what hardware group it has, if it needs electrical attention, if it needs security attention, and we leverage schedules and filters among the consultants to convey that information and to show very clearly what needed attention by what disciplines. That became it replaced our PDF coordination efforts, actually. We went from passing PDFs back and forth to actually just applying the data and leveraging it as a coordination tool.
That's a really, really great tool for all of the disciplines to use. In most projects, the architect dictates what needs to be in a space and where it is in the space. If they have the spec writer in there putting all of that information to the individual elements, we can then leverage that in our own model. We can create templates in different views that leverage that and highlight elements that need our attention. So by doing so, we should have a lot fewer of those misses. They don't need to verbally relay the information that, hey, we placed a water closet here, it needs domestic services. We can simply open up our plan when we receive the new model and it would flag that element hasn't been connected yet. It's new to the model.
Yeah, and that, I think some of the consultants leveraged schedules to show that information, but I know from us, from our perspective, we leveraged the filters and we just had an overwrite that was showing big blotches on the drawing, obvious issues that we needed to resolve. So it was just a great coordination tool. Navisworks played a major role in highlighting the conflicts in our design. This gave us the opportunity to analyze conflicts and find a solution before becoming problematic on site. And we'll touch on that a little more further down the road here.
So on site, while this model wasn't initially intended at the very beginning of design to be handed over, we were fortunate enough to develop a relationship with the contractor, and we did end up handing the model over. Both our firms met with the contractors on site to go over how we modeled the building, what information was in it, and what we felt that they could leverage from it. Again, being early on in a BIM process in years back now, it was 3 years ago that it was handed over, the understanding from everybody was a little vague. So it helped. It went a really long ways for us to sit down with each other. What kind of information did they want to utilize in the model? And then we were able to relay that to what we had in there that was going to help them. A lot of it in this project was spatial recognition, that they could get into the model off of the 2D plans that were our construction documents. They could get into the model, they could spin it around, they could see why we had things in different areas. For people that were on the tour yesterday, you can appreciate on the ground and main floor, we have almost 12 feet of ceiling space, which sounds really, really great. You can run things all over the place. But that becomes its own headache if things get run at an improper elevation. So with the contractor being able to get in there and understand why things were where they were and relative to everything else, it avoided a lot of on-site coordination and headaches down the road.
Yeah, it helps strategize the sequence of construction. Another point there is it also helped give some insight into complex spaces. I mean, there were some areas of the building that were quite complex regarding the design of it. So even just that visual, I'm sure was helpful on site. To the BIM Execution Plan. So in order for us to see the benefits of BIM, it was crucial to have a good BIM execution plan in place. The BEP acted as the project roadmap, information hub, schedule, and dictated what was expected of the team throughout the span of the project. So I'll give a little bit of a breakdown here of what was included in the BIM execution plan. So it started with a description, just a simple project information, including an overview, project name, project numbers, locations, contacts, just a bunch of information that you can always touch base on if you have any questions regarding that. The objectives were laid out clearly. We highlighted the objectives to make it clear that the model was to be used for and what data needed to be applied to the model to meet the goals. This included everything from analysis, cost estimates, coordination, and the contractor handover at the end.
The model management. In order to effectively manage and manipulate across disciplines, it was important to have a structure in place for work sets, naming conventions, sheet numbering, and etc. Specific to the Children's Hospital, we divided the overall floor plans into 4 different quadrants for the efficient sheet layout. File sharing. Data exchange protocols were put into place to create a routine of how and how often the project files would be shared. Throughout the span of the project, we relied heavily on Dropbox to pass that information back and forth. I'd like to touch on that one a little bit. We get some comments about the fact that we use Dropbox as a file sharing method. The reason we used Dropbox was because we were working with so many different consultants that had many different security concerns of using options like BIM 360 now, which wasn't really around or pertinent then. So we understand what's now. There's better tools out there in a lot of methods, but there were a lot of reasons of why we used Dropbox, and it worked very well for us.
Yeah, we're using those tools currently. So Dropbox, we still revert back to from time to time, but yeah, we got to keep in mind it was 2010 when we started here. So that's that was the main source of transferring data at the time. So we'll touch a bit on the model progression specification, which is included in the BIM execution plan. So the level of development matrix is one of the most important aspects of the BEP. This needs to be agreed upon by all consultants, as it includes not only how accurate the geometry is, but what data is applied to these elements. So the Children's Hospital was modeled in most part at LOD 300, which was adequate for the intended purposes. Another thing to point out here was at that time, and can even be argued now, LOD wasn't clearly defined. Now I think everyone has a better idea, but it's not totally standardized yet. There's still a lot of different takes on what each level of development means. So I'm glad, I think, Bill, you touched on that earlier, so I think that's a conversation that still needs to continue happening. Another part of the BIM execution plan that just coincides with the information is the schedule. The MPS is integrated with the project schedule to ensure we're meeting our goals at the appropriate milestones, and that there was enough developed for the clash detections at those milestones. Yeah, so we'll dive a little deeper into collaboration and how we brought together everyone involved in the project. So this project relied heavily on regular design meetings where the live model was used to review areas being focused on. And when I say live model, I mean we're in a room and we have a Revit as our tool at that moment open. So solutions were often found in these meetings, and we were able to update them on the spot in the model. Obviously not through all disciplines, but the decisions were made, and they were made architecturally, and everyone had a reactive design from there. So it was a successful advancement to the project that we need.
So although this project didn't utilize the true live model collaboration that we see today with tools like Collaboration for Revit, everyone followed file sharing protocol and remained very flexible on accommodating model use. That's a really key point, is remaining flexible. Don't dig in your heels with things. Roll with everything. Things change as a project that goes on, and if everybody remains flexible to it really adds to the project. We used DWF files to assist in coordination methods with the model. Methods to start with, but we ended up finding that adding data to the model was, for us, a more effective way of conveying this information. We'll talk a little bit more about that as we move on. It's worth noting, again, as I mentioned, how flexible everybody was in this project.
The level of development, again, I like to kind of circle back and talk about this, because although we agreed on a LOD 300 for the project, and we agreed on what LOD 300 meant at that time, all of the consultants, I think I can say that for all consultants, they went above and beyond the LOD 300 as we discussed it and found the benefits for everybody using it. Not for all elements, but there was definite effort put in to get the information that was valuable into the BIM. So, yeah, I mean, it was we had a great team that was very flexible on this project, and we really appreciate it.
To touch on what level of LOD 300 was for us at the beginning of this project, was really just spatial awareness. Everything was going to be modeled as we wanted it installed, but there wasn't a whole lot of design intent being carried through for smart elements that knew their flows, their fluid properties that were in it, the spatial recognition. There wasn't a lot of that set out in the level of design. Right. But as the project moved on and everybody's abilities grew with it, a lot of that is now in the model. The model is, I would say, in most aspects, a level 400 design as we finish it.
Yeah, it became a lot more data rich naturally, and that was for benefit in the design team. So that was just something that was, it was a good surprise for everybody.
Coordination. This discussion and collaboration is an easy segue into coordination. Let's talk about some of the coordination methods we used on the job. Clash detection. At appropriate milestones, we set aside time to create, review, and resolve areas of conflict using Revit and Navisworks. Revit is used by all consultants on more regular intervals. Revit is a little bit limited on when it comes to clash detection, but it was an effective tool in reducing clashes found through Navisworks. We use Navisworks to complete more thorough clash detections and to produce reports accordingly. After giving all the disciplines time to review, we would meet and review reports and collectively find solutions to problem areas. We'll circle back to that a little bit.
All right. Next is shared parameters. I already talked about this kind of in the depth that I wanted to, but maybe some more examples would be helpful at this point. So I brought up the doors. We were still adding those parameters to stuff like fire-rated walls, walls that needed structural attention if there was something to be hosted on them. There's a lot of medical equipment that required structural attention. It was just an easy way to convey that information.
Fire-rated walls was a great one that we used. So the architect put in a shared parameter, which is actually now inherent in Revit, a fire rating, but at the time it wasn't. So they added a parameter of fire rating that allowed us to view their fire-rated walls. On our end of it, we didn't need to see all of the fine detail of a wall. So we created filters that would filter out to a coarse level, just showing the two exterior lines of the wall with all of the fire rating in between.
Yeah, and again, if a model is managed properly, that information is very easy to push into those elements. So it all comes down to model management at the end. I just move on phasing.
So phasing. We implemented a phase mapping strategy to ensure that the models were reacting properly to the different phases of the project. To build on that a little bit more, there were multiple phases that happened before the actual design of the building went. There was some site layouts, some parkade additions, new entrances, and we're actually attached to the existing Royal University Hospital. This building, by definition, is actually a renovation to Royal University. So everybody had to set up their different models. We all had different varying degrees model existing elements depending when they were installed. And we phase mapped across all of those models so that everything was showing up appropriately based on your phase mapping.
And the phase mapping was definitely key. I mean, if something goes wrong in that process, you can run into a lot of trouble really quick. So we definitely kept an eagle eye on that process for sure. And I hope this video works because it's a cool one. Oh, it's gone. Yeah, patience. Yeah. So this is an example of one of our Navisworks clash detections that we ran on the Children's Hospital. So we've taken out the roof to kind of show the ceiling space, just for the purpose of visuals right now. And we'll show a quick example of one of the tests. We could pan over the building a little bit before we show the test. But,
what we did in a lot of these Navisworks files is we created a list as consultants of what we felt we needed to interference check. We then set off that list to HD, and they would run the files through Navisworks, creating all of the interference reports. We then take those reports, and with each element that had an interference, it would give you an element ID. We were then able to go back into the Revit model itself, search that element ID, and Revit would take you specifically to that instance, that interference instance. We were then able to decide collaboratively if that interference needed attention and what implications it had. Just because we can see every interference that there is, sometimes it's not beneficial to spend the time to avoid that interference in the model. In something like this, where we've got a piece of ductwork going through a structural beam,
just move the beam, right?
Yeah, just move the beam. Make the beam smaller. Structure makes things too big all the time anyways. But this is a good example. There may be a very good reason why that piece of ductwork is there. And maybe it needs to go through the beam, and maybe that's an option. In most cases in this building, it wasn't. We had the space to avoid it and route otherwise. Here we've got a video where we'll see a Revit view showing the level of coordination in a congested area. So we've got a mechanical service chase here. It was a very small service chase that needed to be accessible. So we went through and actually modeled all of the pipe hangers and rollers. And as we move up here, you'll see one of the mechanical shafts. There's 4 main mechanical shafts through the hospital that distribute services from the penthouse down and from the sub-basement back up. As we come up these service chases, they're all accessible on each level through a doorway for servicing valves and different things. So you can see with offsets in the ducts like this, we're actually offsetting to avoid different elements above, whether it be the doors into the shafts, because the doors were at all different locations into the shaft based on the floor layouts. We've also got some piping here that avoids a structural member. Things like this have implementations in a plan. If you offset, that pushes something else out. In 3D, we're easily able to see that with Navisworks and the clash detection and it saves a lot of time and a lot of thought is put in beforehand in design that really saves time on site.
Did anybody see a conflict?
Good answer.
Yeah. All right, so 90% working drawings. We're almost there. Everyone's happy. Almost high-fiving each other at this point. But no, 90% redesign at this point is what happened. So to discuss a little bit what happened here, as the project was advancing, the province was growing. So after 3-4 years of being on the project, a population study was conducted again, and the result was we needed more patient rooms by about 15% of program space. In order to accommodate this new population projection, we had to go totally back into redesign mode. So 15% program space, probably more building area added than 15%, and definitely big implications to the rest of the building. So yeah, it was kind of a eye-opener.
It was. It really was. So with this stop work and the 90% redesign, we need to come up with a strategy model-wise of how we were going to handle that. What were we going to do to add all of this space? We developed a reasonable schedule for the work order. We did a save as of our models to hold all of our design intent that was there. We didn't really know where we were going to go from there, if we were going to lose information as we moved forward. And we developed a workflow for sequence of design and analyzed the different implications to structure and mechanical systems.
And I can't quite remember what the schedule implication was there, but I know it was relatively tight.
It was really tight.
For redesign,
yeah.
So we'll talk about the execution of this redesign. So a significant portion of the building needed to be redesigned. The first step for us was to salvage and relocate where these details were being derived from. So for the most part, we were pulling information and deriving these details right from the geometry of the building. So a lot of them came from that portion of the building. So we needed to relocate. Actually, there's somebody in the audience who solely did that. So it was just a matter of grabbing the data, moving it to another similar area of the building, and leveraging that portion of it during the redesign stage. So the data helped us there. The second step, our strategy and the use of our data applied to the model truly made this redesign a success in regards to model management, workflow, and project schedule. Where are we at, Jerry?
Yeah. Just a quick little image of where we're at 90% redesign with the stop. Moving forward, you can see on the second and third floors, as well as the mechanical penthouse, how much floor area we really did add.
Okay, so we'll quickly touch on the contractor model handoff. This was a milestone for us. First time we were ever part of this handover. And this data we could see it being beneficial to the contractor. And I think there's reps from Graham here, and I think they'd agree that they used and leveraged the model to cut back sections, to visualize the space, to better strategize sequence of construction. They could keep track of changes they were making on site. It wasn't the same model being used, so they were using a different model with some information stripped that we didn't necessarily need them to have. And it was a successful implementation of that. So we had the opportunity to see how they were using the model, and we're able to give them advice on how best to manipulate the views for their use. I think it's safe to say every firm of any discipline has different standards from firm to firm. So it was beneficial for us to go in, sit down, and kind of give a breakdown of how these models were set up and how they could manipulate the views and the information for their benefit. So again, insight into complex areas and just a better understanding of design intent was definitely a benefit in the handover.
We're also really fortunate to have contractors that were willing to get into the model and dig into it, and they leveraged it very well, and it was beneficial to both parties to have the contractor having the model at that point. It saved a lot of back and forth on phone calls.
So another quick video here. This one is also awesome. This is called the snake pit, and it is the HVAC.
Yeah, so this is just our mechanical ventilation system. No piping of any sorts are shown in here. You can really see how much the HVAC follows the building. When you're looking at it at the beginning of the slide there, it's a little overwhelming. as we rotate through, you can really see by modeling in 3D how everything is defined in its different layers, as well as the colors that we mentioned earlier and Edwin touched on. So everything we modeled was color specific to its system, broke out very well.
All right, I'm going to skip the next video. It's another Revit view, basically showing a congested mechanical space of how the contractor would be able to strategize their work in that area. So I'm just going to skip that because I know we're tight on time here, and it's another Revit view. So that wraps up the presentation. In closing, we'd like to leave you with a few takeaway points.
Know who needs the model, know who needs the information, and get it to them efficiently. Data-rich models are hugely beneficial to everyone involved in building. Promote the use of this information and develop BIM accordingly. Don't be afraid to try new tools and technologies. Don't be afraid to fail. Do your research on what's out there, and with proper implementation, the successes will always trump the failures. Communicate. Develop relationships. The amount of data being shared is substantial, and communication is essential when creating an efficient workflow in a BIM atmosphere. And strive to offer more. Push the boundaries with the goal being the information, providing the most useful information post-construction.
Remain flexible. The BEP is a staple for every project, and the Children's Hospital is a great example of that. This being said, listen to your team. We came across multiple methods that were not dictated by the BEP that leveraged the data in ways we weren't expecting at project startup. The shared parameters being an example of this. Build a relationship with those on site. These models were huge, and all companies manage their models a little differently. As the contractor opens these models on site, a little guidance goes a long way and is greatly appreciated. It sparks that conversation, and it's more of a collaboration between the entire project team. And last but not least, BIM benefits projects of any scale. Be it the Jim Pattison Children's Hospital or a residence or small business, BIM can be an asset in many different ways. We just need to know how to explore them and get that information efficiently passed through. That's the end. I don't think we have time for questions, but feel free to approach us in the hall. That's what we're here for, so we look forward to discussing it further.
Thank you very much.